Welcome to an update on the AI/ML Analysis Working Group. It's hard to believe it's been a year since we first convened, but our progress in this inaugural year has made us all the more excited for things to come. Essentially, our group focuses on machine learning applications for gaining new knowledge from the data available through the OSDR. Traditional data science is rooted in statistics and focuses on hypothesis testing, model interpretability, and understanding relationships between variables under strong data assumptions. By contrast, machine learning prioritizes predictive accuracy. It is characterized by its ability to handle large, complex data sets with fewer assumptions about the data structure. While traditional methods excel in inference and providing insights into data, machine learning is adept at discovering patterns and making predictions, particularly with high-dimensional and unstructured data.
The datasets from OSDR are immensely valuable, yet they do pose significant challenges for AI applications. The rarity of spaceflight biological data, the high variability inherent in omics data, and the need for consistent, detailed metadata are some hurdles we're currently tackling. To address these challenges, our AWG has engaged with several projects. Our AWG member, James Casaletto, has initiated a new project to evaluate the potential of phenotypic data interpolation and generative methods for developing a digital twin for mammalian spaceflight using data housed in OSDR from the Rodent Research 9 mission. This project also includes efforts for anomaly detection from environmental data and causal inference from multimodal data.
Additionally, this summer, our AWG collaborated with the ALSDA AWG to develop open source training materials for high school students focused on data analysis and machine learning. We trained 9 awesome students in our pilot program, and some are attending ASGSR this year to present a poster sharing some of their findings. This program will be expanding next summer, and we welcome your contribution. To further engage with an expanded research community, we submit proposals to conferences relevant to AI/ML, like NeurIPS and GTC, and plan to build a stronger presence in the coming years.
Looking to the future, our AWG is interested in employing advanced strategies such as transfer learning, which can leverage pre-existing models trained on large terrestrial datasets, to bootstrap models for our more niche space biology data. Few-shot learning techniques that can make the most of limited data points, robust data augmentation methods that can artificially enhance our dataset size and diversity, federated learning to collaboratively train models on decentralized space biology datasets while maintaining data privacy, and applying digital twinning to create and test simulations based on these models, enhancing our predictive understanding of biological responses in space environments. We meet monthly on the second Tuesday to hear from invited speakers, discuss ongoing projects, and share news within our community. We have over 130 members from across the globe with a broad range of expertise. Moreover, our research and writing subgroup meeting on the first Friday of each month focuses on writing manuscripts, grant proposals, and brainstorming new projects. We're currently starting to write a review paper on digital twins for space biology. So if you haven't yet got involved or are looking for more ways to contribute, we invite you to join us at our next monthly meeting. We also encourage you to meet our colleagues, James Casaletto and Brian Everts, who will host our roundtable discussion today. Thank you for your dedication over the past year, and we are looking forward to seeing you at our upcoming meetings.